All right, good afternoon, everyone. Welcome to day one of VMworld, depending on how you count days, because I know it started yesterday. But yesterday's Sunday, it doesn't count, because I didn't have to do anything, so that's what matters. So my name is Denny Cherry. This is SQL Server on-premises and in the cloud. I've got business cards up here if anybody wants one. There's some lovely marketing slides that VMware asked me to put into the presentation here that talk about how awesome virtualization is on SQL Server, but you already all know that because you're here. Do check out all the other sessions that are being presented on this track. Specifically, there's a spotlight session on Travis Credit Union and how they went 100% virtual with Oracle, although we're talking about SQL Server in this session. We do have 30 breakout sessions with 2 different panels and 3 quick talks in this track. So be sure to check out all of that if you haven't already signed up for it. Here are the various other speakers that are available in this track. I don't know why my name is flashing, but it just is. All the other speakers here are very good, except for Tom, who's sitting in the front row. He doesn't know what he's talking about. So there's a couple books that you can buy from VMware Press, so enough of that. Let's actually talk about me, because that's the thing I love talking about the most. So, like I said, my name is Denny Cherry. I am the owner and principal consultant for Denny Cherry & Associates Consulting, based out of lovely San Diego, California. It's a very short hour-and-a-half flight from here, or a 9-hour motorcycle ride, as I discovered on Saturday afternoon. Yeah, I was dying yesterday. I have written 8 books mostly on SQL Server, including Securing SQL Server, which is that big blue one right there. I've written dozens of magazine articles for various magazines and websites, including SQL Server Magazine, WinIT Pro, MSDN Magazine, TechNet Magazine, probably a few other ones I can't remember. I am a Microsoft MVP for the data platform product. I'm a Microsoft Certified Master for SQL Server 2008 and 2012, and I am also a VMware vExpert. So basically all that means is that I talk way too much in front of audiences instead of billing customers. Click, damn you. There we go. So here is what I want to talk about for the next roughly 59 minutes. We're going to talk about cloud and on-premise and kind of what those 2 differences are between those 2 deployment options. We're going to look at always-on failover clustering, both in a single and a multiple site, since obviously high availability and disaster recovery are huge, huge problems we need to solve. We're going to talk about always-on availability groups, both in a single site, a multi-site, and going both on-prem and to the cloud. I'm going to talk about Azure, but that's just because that's the platform I have the most experience with. Everything I'm going to talk about when it comes to cloud will work the same in any of the cloud environments. So if you're in Amazon, if you're in VMware, if you're in IBM's cloud, Verizon cloud, pick your cloud environment. This will all work basically the same. And then we're going to talk about kind of some of the stuff that's new in SQL Server 2016 that you can leverage for your environments and for your deployments to get some better solutions available to you. So let's look at the differences in the cloud and on-prem. So the first thing to remember with SQL Server is it doesn't matter. SQL Server does not know or care how you're deploying it. As long as you've got SQL Server installed and up and running, it's going to let you do whatever you need to do without any real difference to the product of the platform. When you're running code against T-SQL or against SQL Server, you're just running T-SQL. So it doesn't really care what the base platform is underneath that. As long as the I/O is fast enough, as long as the network is there and fast enough, that's pretty much all it cares about. Everything else is just where it's running. Is it a VM running on your hardware? Is it a VM running on somebody else's hardware? Some of the clouds are going to have some specific quirks when it comes to getting things set up, specifically around high availability. So there's little bits and pieces that we're going to talk about that are going to be a little bit different for those various cloud environments, but those are, you could consider those more of an infrastructure change, not necessarily a change to that SQL Server deployment itself. Like I mentioned, SQL Server does not really know if it's on-prem or in the cloud. So those little changes you got to make for high availability when you're in a cloud-based platform. If you're working in Azure, then you're going to need to create what's called an internal load balancer. This just tells the Azure infrastructure where it needs to route that data to which physical host and which VM running on that physical host it needs to route that traffic to internally. This is not a SQL Server object. This is an Azure infrastructure object that you create. You used to have to do this through PowerShell. Now you can do it through the portal and deploy it with everything else that you're working with. If you're deploying things up to Amazon, to AWS, It's basically saying normal SQL Server deployment. Their big requirement there is that you can only deploy one node per region when you're deploying out to the Amazon cloud. The reason behind this requirement is because how they deal with IP addresses and the fact that you cannot move an IP address from one VM to another. All of the HA solutions we have in SQL Server are going to require moving an IP address from server A to server B when that failover happens. So there's no way to do that in AWS without having them in multiple regions, because that gets us a multi-subnet cluster. So that's how we get that failover to be able to happen in those Azure-based environments. In vCloud, from what I've seen, there's really no difference. There's nothing special that we need to do in vCloud Air to actually get a high availability solution running on SQL Server in the virtual machines in a vCloud Air environment. So let's talk about failover clustering. So who's built a SQL Server failover cluster before? Okay, who hated the experience? Just out of curiosity, only about 5 of you? Okay, that's not too bad. Normally everybody hates the experience, but you guys are probably too young to have done it on old versions. So in SQL Server, when we're building a cluster, we're building that on top of Windows failover clustering. So Windows failover clustering is Microsoft's failover. It's their high availability solution for the Windows operating system. So every high availability solution we have in SQL Server today, with the exception of database mirroring, which is going away as of this current version of SQL Server, all are going to be built on top of this failover clustering solution. So this is going to do all of our failure detection and failure notification. Back when the SQL Server team built database mirroring, back in the SQL 2005 days, they tried building all this stuff themselves. They didn't do the greatest job of it. So because of that, they've offloaded all that to the failover clustering team, who does do a very, very good job at all this failure detection and triggering of failures. So the downside to failover clustering is we have a single set of database files. So we need to present the same storage to multiple VMs. So obviously this can be kind of a problem in the VMware world. How we get around this is everybody's favorite solution of RDMs. I'm sure we all love deploying lots of RDMs, or shared virtual disks. So those are basically your two options. Shared virtual disks, I think, just came out in the latest build of VMware. So those are going to be relatively new. If you're on something like 5.5, welcome back to RDMs. That's pretty much your choice there. So that does technically give you a single point of failure for those virtual machines, but it's not the end of the world. There are actually some third-party solutions you can use to get around this problem. So you can use local disk for each of your VMs. The one I use the most is from a company called Sios. It's called Sios Datakeeper. They've actually got a booth here at VMworld. They actually do block level replication inside the VM. So you can effectively, as far as Windows is concerned, have the same storage presented, but you have actually different storage presented each VM, and the VMs just have VHDKs. Yes, sir?
Do you anticipate this changing with Windows 2016 reserve being able to use that? Windows clusters. I don't know if 2016 is going to support on it right away, or what the story is there.
So his question is, how is this going to get better with Windows Server 2016 at the guest level and SQL Server 2016? So Windows Server 2016, if you're not aware, introduces the storage spaces. And that is going to let you stretch your storage across machines, kind of like vSAN does in the VMworld today, the VMware world today. So yes, that would help you. That is going to be supported on SQL Server 2016 once the Windows Server 2016 comes out. There's probably going to be a hotfix required to SQL Server to make that work because of just the way things are staged and coming out of Microsoft. Because SQL Server is not allowed to rely on anything that's not already GA when they announce. So when we build our typical failover cluster, what we are doing is basically spinning up multiple machines, all running the same SQL Server instance, all pointed at the same disks. So if all our data files are stored on the E drive, and we point everything to the E drive, we can, we simply move the instance from one VM to another as we're spinning those up and down. Only a single one of these machines is going to be able to be configured to run any one of this instance at any one time. So we're not getting any sort of scale out functionality here. It may look from a logical perspective kind of like an Oracle rack deployment where we've got lots of machines all with the same instance installed. Maybe we can spin them up all at the same time. We cannot. We're only running the instance on one box at any one time. So it's kind of pinned to an operating system. Hey, look, I have a diagram. So here we have two machines. So we've got one VM here, we've got one VM here, we've got some sort of shared storage sitting underneath here, and then we've got failover clustering encapsulating this entire thing. We've got at the top here a virtual network name. So this is going to be, and a fly apparently flying around inside the projector. So that virtual network name is going to be the name that the users connect to. So that's going to be a floating network name. It's going to float from one server to another. So when a failover happens, we simply move the instance from point A to point B. We're never running that instance on multiple servers at the same time. The Windows failover clustering is preventing anything running on, at this point, node A from seeing the hard drives that our database files are residing on. That's why we cannot run things all on the same machine at the same time. If we were able to somehow get SQL Server started on node A, it would either not see the database files, or if we had really screwed up the storage, we would end up corrupting the hard drive, and we'd end up corrupting the file system on the disk. So obviously, both of those would be bad situations to be in. We can also build much wider clusters as well. So your two-node cluster is kind of your standard deployment. That's where we all start. But as we get bigger and bigger environments, larger and larger clusters start to become something that we need to look at, mostly for hardware costs. So that's obviously a bigger deal in the physical world, but it still can matter in the virtual world because we don't want to be running 30 or 40 VMs that are passive nodes sitting there doing nothing. I'd much rather build an 8-node cluster with 1 or 2 passive nodes than have 6 passive nodes because I have 6 2-node clusters sitting around my environment. Personal preference, I don't like wasting resources, and obviously the people that cut our paychecks don't like wasting those resources either. So when we do this, we spin up multiple boxes. Again, we have to have shared storage underneath. We present one set of shared storage or shared disk to each of the SQL Server instances, and we can then spin multiple instances across this large environment. So we have one passive node at the end here, and then we've got 3 instances at this point, one running on each VM within the environment. If we fail any one of those 3 machines, that instance simply moves over to node D and starts running there. Now these do get a little more complex to configure. They do take a little longer to configure because SQL Server does not like it when you start installing things in parallel in these large clustered environments. If you do decide to try and build one of these larger side-by-side environments, plan on several days to actually get everything installed and configured, even with automation, just because of the amount of time it takes to install SQL Server and then run the patches to actually get everything installed. Now, the requirements for installing these and getting everything configured, each of these instances are going to be installed and managed separately. So even though we do have kind of this one instance of SQL Server that's running in the environment, we are going to end up by having to manage and patch all these various nodes in the environment automatically. If anybody remembers working back in the SQL 2005 days or SQL 2000 days, you'd install a clustered instance and all the patching and everything would happen automatically on all the nodes. That all went away back in the day. We now have to patch and manage each one of these boxes independently. That's both good and bad. It's bad because I now have to go install Service Pack X 18 times, but it's good because I get to install that Service Pack on a specific box on the passive node. I can fail over to that passive node, make sure everything works. If it doesn't, I can fail back and my database is still running on the old version or on the old Service Pack level. I can make whatever changes I need to make and then try failing back over. We can do sort of the same thing for version upgrades. We can upgrade one node of the environment. When we're ready, we can actually do that failover. The cutover time to do an upgrade is extremely short, 10, 15, 20 seconds, but there's no fail back. Once you've failed over, you're now on that new version when you're doing that rolling upgrade process. So obviously a lot of testing in advance is going to be required to make sure that's going to work for you. We do have to do that SQL Server install on each one of those nodes to get this up and running. And again, that takes quite a bit of time to get done, so plan accordingly. Whenever we're building a failover cluster, we require a separate network name and IP address. Again, this is what the users are going to connect to. So if we're just doing a single site, say 2-node cluster, every instance we install on that cluster is going to need its own network name and its own IP address, because there's no guarantee that machines are going to be running on the same nodes, so everything is addressed separately. And we do that for reliability, so we can always make sure we're talking to the right SQL Server instance when we're failing things back and forth. Every SQL Server instance is going to require at least one clustered hard drive, one piece of shared storage to work with. You can have, obviously, multiple disks. You can use mount points. They are fully supported with a clustered SQL Server install. I know there's a lot of rumors out there about them not being supported, but that is definitely a supported solution to put those, to use mount points. That way you can get more disks onto the server and get the I/O throughput that you need. You can also separate your resources out across multiple LUNs or across multiple vertices that way. So I've talked a lot about the instance and the instance of SQL Server, and we do kind of redefine that instance a little bit when we build things in a traditional failover cluster. So we're installing this instance on multiple machines in the environment, and that's how we get this failover, so we can move that instance back and forth. Each single clustered instance is going to have the same name, so you can have what we call named instances in the SQL Server world, where we can have multiple instances in the same environment or running on the same machine, just each with a different addressable name. So we can do that in a clustered environment as well. You can have as many instances as you want in a single failover cluster, up to 25. The reason we hit 25 is we run out of drive letters. We can only have 25 drive letters because the C drive is going to be reserved for Windows. Like I mentioned, every instance is going to have its own network name that it's going to be dealing with. So when we set up our cluster, the SQL Server installer is going to go through and set up a lot of dependencies for us. So as we go through that install, it's going to ask us what disks we're going to be using. It's going to ask us what the name and the IP address are going to be. And it builds dependencies across all of that so that things are able to come online in the appropriate order. The reason things have to come online in the appropriate order is because if SQL Server starts before the hard drives are ready, there's no databases for it to use. That's kind of a problem. So we build dependencies in Failover Cluster Administrator that tells SQL Server, do not start until your network name and your hard drives are online. Do not start the network name until the IP address is online. So everything's got to come up in that right order. Once everything comes up successfully, SQL Server starts, and then the SQL Server agent comes online. I just talked about that. So there have been quite a few enhancements to the SQL Server product over the years when it comes to high availability. So in SQL Server 2012, we got some pretty good enhancements. These were a pretty radical change from what we had back in the SQL Server 2008 days. So the first one of those is the multi-subnet failover support. So this let us do a multi-site cluster without the need to stretch our VLAN. Obviously, stretching VLANs is a royal pain when it comes to getting things set up across two sites. So we can now get that support out of the box by simply telling SQL Server, this is your IP address in this site, and this is your IP address over in this site. We got network storage support. So this allows us to use much more common storage, and we can now use storage over on an SMB3 network share. So one of the options we can use to deploy a failover cluster under VMware is to have a file server sitting out in the environment somewhere, running Windows 2012 or above, and we can use a network share target on that file server as the storage for our environment. Or we could use any sort of NAS storage, anything that supports SMB3 basically we can use. And we'll get the same level of throughput that we're expecting as if we were running it on local disk. One of the things that I really like and that gets used almost never is support for Windows Core Mode. So this lets us do a nice, thin, GUI-less install of the Windows operating system while still supporting failover clustering. Now, I try getting people to deploy this in VMs because it makes the VMs thinner, and a thinner VM allows us to put more VMs on the host. But frankly, not many people like doing this because not having GUIs is very scary to Windows people. I'm a Windows person. I like my GUI, I freely admit it. There's people in the room that know me, and they will happily vouch for that. One of the other really cool things we can do with TempDB in a failover cluster in SQL Server 2012 is we can actually put it on local disk. So one of the things we were required to do up through SQL Server 2008, whenever we configured our TempDB, that's just kind of our scratch space for SQL Server, is we were required to put it on shared storage. We were required to put it on SAN storage. Obviously, SAN storage is very expensive, and it's not always the fastest thing in the world. And it's also fairly hard to configure in VMs. So now what we can do with TempDB is we can actually put it on some local resource that is not a shared resource. So we don't need to replicate that data out to the other VM. So if you've got your standard config of binaries on C, you could do your D drive as your TempDB drive, which is a non-shared local VHD drive. And then you only deal with RDMs or network shares for your actual system and user database files other than the TempDB database. For systems that have very high I/O requirements for TempDB, this can be a huge performance gain because we may be able to put some sort of higher speed storage or faster storage that we dedicate just for that local disk. When we're dealing in the physical world, this can obviously be a huge gain because we can throw PCI-based SSD cards in those local servers while still getting high availability for our environment. One thing I will caution you on, do not put the TempDB database on the root of whatever drive you put it on, because you will end up with problems from Windows. There's that whole security aspect of Windows that it likes to lock things down and complains when you try to do things on the root of a hard drive. The same applies to the SQL Server service account. So always create a folder if you're going to put your database files on there. Mostly I see that as an issue in Azure because of how they do their scratch space on their D drives. So when we go to multi-subnet failover, so I talked about this for 2 seconds. So basically what we're doing is we're putting 2 different IP addresses for our SQL Server instance within our failover cluster, one in each site. So whichever site owns that IP subnet, that's the IP address that's going to come online. So only one of those is going to come on at a time. When we're configuring the dependencies, we're going to use an OR statement in the dependency configuration to actually configure those dependencies. So the really interesting thing about this is there's actually a couple of different ways you can set this up, because this is actually tied to some other features, which I do not have slides on, which I probably should, for failover clustering. And one of those is the multi-subnet aware connections that SQL Server is going to try to do. So this is one of the places where I personally think Microsoft made some, we'll call them interesting decisions. When you spin up a multi-site failover cluster by default, it will register both IP addresses in DNS. So site A and site B. Now, only one of those IPs is going to respond. So that's the default config. On the client, on the users that are connecting to the SQL Server instance, by default, they will go to DNS, get one of those IP addresses and connect to it, the way you would expect things to work. You can go into the connection string of the application and give it an additional connection string attribute that says allow multi-subnet failover or something like that, or multi-subnet failover support equals true. What it does at that point is it actually goes and connects to both IP addresses at the same time that it gets back from DNS. Whichever IP address works, it uses. It simply terminates the other connection. Why they're different, why it registers both on the server by default but does not use that setting by default on the client, I have no idea. But Microsoft, in their infinite wisdom, decided to set it up that way. Now, the reason that setting of registering both IP addresses is good is because it allows for faster failover. By default, if I were to change that and make it so that it only registers its current active IP address, when I do a failover from site A to site B, I've got to wait for that DNS change to propagate across my entire environment. So that could take anywhere from a couple of minutes to half an hour. So that's a much longer outage. So when the users come back and say the application's still down, my response to them is, well, the database is up. It's not my problem. So that's obviously a really bad situation to be in when it comes to an actual DR failover. So we want those 2 IP addresses registered so that when we do that failover from site A to site B, the users launch the app, they connect, and it just connects to both IP addresses and works. Now, the catch to this is it requires the SQL Server 2012 or newer driver. So the SQL 2012 or 2016 driver, which means you're going to need to test the application to make sure the application works with that version of the driver. So that's the SQL Server native client. If it does not work with the new version of the driver, you're going to have to turn that feature off in SQL Server and then go clean up DNS and replicate that cleanup before your users are going to be able to successfully connect to the failover cluster that you've built. So this requires a little bit of understanding of what SQL Server is doing under the covers and why it's doing the things it's doing. Otherwise, you can end up in a bad situation awfully fast as soon as you set up that multi-subnet clustering for your environment. Where this is really going to bite you is where it bit me when I forgot about it at one client. They had a 2-node environment. We were adding a 3rd node in their DR site, and I forgot to go turn this feature off beforehand. And I brought their box up. I gave it the new second IP address, and SQL Server happily registered it in DNS, and the site went down. That was awesome. Fortunately, the client was very understanding, as it was 1 o'clock in the morning when we did the change. And they were wondering why I insisted on an overnight outage. So, in SQL Server 2014, we actually did not get very many features added to high availability. The big one we got was the support for clustered shared volumes in Windows 2012 R2. So what this gives us is the ability to do, again, that kind of vSAN configuration, that same sort of idea, but we can do it inside the VMs so that we don't have to deal with that shared storage. It gives us support for that in SQL 2014. This does require apparently what I called Windows 10 Server, which is actually Windows 2012 R2. And obviously you're going to want SMB3 because you're going to want to get all that functionality and all that performance moving around. That is not the right thing I want to click on. There we go. So if you're doing things in Azure, is anybody working in Azure? A few people, all right, about a third of the room. So failover clustering actually has been supported in Azure for their SQL Server environments as of April 1st, 2015. That was not a bad April Fool's joke. It was actually supported on that date. I keep telling them not to do things on April 1st, and they just don't listen to me. This does require that third-party storage replication support, such as Sios DataKeeper. There's some caveats here. You're only going to get a single instance per cluster. This is due to that internal load balancer requirement that I had mentioned earlier. The big problem here is you can only have one internal load balancer per VM that you're pointing the internal load balancer to. So if I try to build a second internal load balancer for a second SQL Server instance, it will fail, and it will not let me create it. We covered all this. All right, so let's talk about always-on availability groups. So always-on availability groups were introduced back in SQL Server 2012, and they give us a lot of new functionality and a lot more flexibility than we got back in the failover clustering days. So these are just some of the terms that go along with failover clustering. Things like hybrid cloud, so we can do part of the environment on-prem, part of the environment up in say vCloud Air, for example. We've got lots of flexibility on how we want to set things up and how we want to move things around. So there are some new terms that you need to know to go along with always-on availability groups in SQL Server 2012 and above. So the first one is the availability group. This is just the logical container that's going to contain all the other things I'm about to talk about. We have availability replicas. Those availability replicas are simply the instances of SQL Server that are hosting what we call the availability databases that we're going to be moving around. So these are just SQL Server instances, but we call them replicas because it's Microsoft and they like to give us new terminology to learn and new ways to talk about things. The availability databases, these are simply the databases that are being protected by the always-on availability groups feature. That's pretty much all they are. Then the last one is the availability group listener. So this is simply the IP address and network name that our users are going to connect to when we actually connect them to these always-on availability groups. Now, for a VMware audience, the thing you're going to love about always-on availability groups over failover clustered instances, no more shared storage. All that shared storage stuff that I talked about before all goes away. So we can do everything with VMDKs. Sorry, wrong audience. That's the Microsoft terminology. So with the always-on availability group, everything's local disk. We don't have to have shared storage anywhere. So we have our 3 VMs, 2 in Washington, 1 in Chicago. We have our availability group underneath that, or rather above that, and that's just simply replicating our data across. Yes, sir? SQL Server licensing question. I love it. How do you have to license this monstrosity? So with SQL Server, and big caveat, check with your SQL Server licensing specialist at Microsoft to make sure that what I'm saying is true, because it depends on your contract. If you have an enterprise agreement and software assurance, you'll get one of these licenses for free when you buy this production license. So you get a passive node for free. This is a change. You used to get a passive node for free for every license that you purchased. Now you get a free license in the environment. It all depends on what your enterprise agreement says. So before you sign that EA, beat down your Microsoft sales rep or buy them beer and whiskey, whatever works best for you, and get them to try and get them to throw in as many free licenses as you can get for every one that you buy in this environment. So based on the official published docs, in this environment, I'd have to pay for 2 of these 3 licenses. Now, what I would do is, because I'm paying for a second node, I would use it. So if I'm paying for boxes, I'm going to use them. Now, the cool thing about always on availability groups is I can use my secondary nodes for read-only workloads. So I can run reports against them. I can check for database corruption on them. I can run my backups on them. I can move all this workload off that production instance onto my secondary instances. So if I've got a 24/7 workload and I need to offload those backups so that they're not running on that production box because my production workload suffers because of the I/O, I can simply have my production workload here. I can take my backups here and write them off to another disk. Yes, sir?
Can you do that on Node C?
The question is, can you do that on Node C? Yes, you can. You can run that on, you can run those backups, you can run those consistency checks on any nodes as long as they're licensed. I'll throw the legal caveat out there. So as long as the box is configured to allow a read-only workload to it, you can take your backups on it, even if it's an asynchronous copy off on another site. Are you paying for core-based licenses? Give me a sec, Tom. So if you're paying for Enterprise Edition, yes, you're paying for core-based licenses. That is still the only licensing option. Gee, thanks, Microsoft. That's unfortunately the only way to buy Enterprise. Now, if you're buying Standard Edition, this has been introduced in Standard Edition as what we call basic availability groups. I've got slides on that later in the deck that I'll try and get to. That will let you do some of this, but not the read-only workloads. But that will let you buy without a core-based license.
Aren't there still some workloads you can run on a node without having a license?
Are there some workloads you can run on a node without having a license? Not as far as I know. As far as I know, the only work you can do on an unlicensed node is administrative work. A backup is not administrative work, according to the lawyers at Microsoft. An administrative workload would be, I'm making sure the instance is up. I'm putting a job on to do checks to make sure to do backups if it's the box that should have backups run on it. That sort of thing is an administrative workload. Things like backups and consistency checks, as far as I've been told by the lawyers at Microsoft, require a read-only, a license on that box. Now, the cool thing is, there's nothing that says that this box that you have to pay for has to be the same size as this box. So if this is an 8-core box or 16-core box to run your production workload, well, let's make this a 16-core box because it's free. Let's pay for 4 cores for this guy. In the event that we fail over to DR, we have resources. We can run the work, run production. It just won't run as well. We can scale that box up later. Our licenses will all transfer to it because we have license mobility, because we have an enterprise agreement, and we've paid for software assurance. This is, I haven't been told I can't do it. and all the talks I've had with Microsoft licensing, they've never told me not to do that. So it sounds like I can do it. So if you've worked with database mirroring, in the olden days of SQL Server 2005, is this just basically the same thing? And from a conceptual point, a lot of the things in availability groups are going to look very much like what we used to have in database mirroring. So if you're running in an all virtual environment today, you probably have database mirroring in place in some places, simply because it doesn't require shared storage. Other than that, it kind of sucks, because it's a pain to configure, it's a pain to fail over. If anything breaks on it, it's very sensitive. So we keep some of the concepts of database mirroring in the availability groups, like how we get the data from point A to point B, but that's pretty much it. Everything else has been kind of rewritten from scratch at least once, if not a couple of times by now. So we are just using a transaction log stream to move data from point A to point B. So SQL Server is just piping that data across the network in a real-time stream. If we have a synchronous copy, we are using two-phase commit. If we're going to an asynchronous copy, it's one-phase commit, and data is just going to get there as fast as the network will allow it to get there. Everything is going to be encrypted, so you don't have to worry about any prying eyes on the network or any prying eyes on your site to site as you're going from point A to point B. All that data is going to be encrypted and secured as it goes across that network. Like I said, we can make the secondaries readable. That is optional. We have automatic failover if we're going to be going to a synchronous copy. In SQL Server 2012 and 2014, we could only have automatic failover between any two copies that were synchronous. In SQL Server 2016, one of the new features we get is the ability to fail over to any synchronous copy. So we can have up to 3 synchronous copies in the environment. And I see phones, so I'll leave that up for just a second. So depending on what size of, or what edition of SQL Server we're running, or sorry, what version of SQL Server we're running, we can have different size configurations. So in SQL Server 2012, we were limited to 4 replicas. So of those 4, up to 2 of them could be synchronous, or up to 4 of them could be asynchronous. With the introduction of SQL Server 2014, we doubled the size of the environment. We can now go to 8 secondary replicas. Still, only 2 of those could be synchronous. So total of 9 servers, primary, 2 synchronous copies, and then 6 asynchronous copies. That's as big as it gets, or up to 8 asynchronous copies total. In SQL Server 2016, they actually did not make things bigger. I was actually really surprised by this. I was expecting them to introduce more nodes into the environment, but we are still capped at a total of 8. The change they gave us here is, again, in SQL 2012 and 2014, I could only do automatic failover to one of my secondaries. Now I can fail over to any of my secondaries, or synchronous secondaries. It's just a matter of me defining what order I want the priority of that failover to happen in. And I do that in SQL Server and the availability group configuration. Now, if you're a glutton for punishment, you may be asking, how can I combine always-on availability groups and failover clustering? So we can build availability groups on top of failover clusters to get a different layer of availability. So this is the same kind of conversation we're going to have if we're going to talk about why do we want to do high availability of our SQL Server instances when they're inside a virtual environment when we already have HA at the virtual environment. And the reason being is because we might not meet our requirements of uptime through the HA that's built into VMware. If I lose a host that's running my SQL Server environment and I'm not clustered, it may be a few minutes before that SQL Server comes back up. For most servers, that's probably okay. For the server that's servicing our customer-facing website, that's making us all our money, that's probably going to be a problem. So that's why we build HA inside our VMs. Why we would build availability groups on top of failover clustering is for different layers of high availability, or because we need to meet different sorts of requirements. So this does allow for additional redundancy at each site. So for example, if I had a requirement that I always have a passive node available, even in the event of a hardware failure at every one of my sites, this would be a way to allow me to do that, because I could build 3 node clusters at all my various sites and then use always-on availability groups to stretch those, to replicate that data between those. Each failover cluster at each site becomes a replica, even though there's 3 boxes running underneath it. So this can give me a lot of availability and allow me to stretch my workloads out and control how things are working and how I'm moving data. Now, caveat to this, because this is IT, nothing's free. We get this extra layer of availability, but we lose the ability for the availability group to do automatic failover. The reason we lose this is because if the availability group could do automatic failover, it would fail over every time a failover cluster failed over. So we'd end up with this chain of things failing over, and we'd end up with actually more downtime, not less. So we don't get that automatic failover. So we get automatic failover of the failover clustered instance, and the availability group just stays where it is. If the entire site were to fail, somebody's going to need to manually fail that over to another failover cluster. Now, there are a few features of SQL servers that are supported by always-on availability groups. What those features are is basically yes. If it's in SQL Server, it's pretty much going to be supported with always-on availability groups. There is one big caveat, and I love the way the stage is set up, so I can actually point to it. You'll notice here, of replication, there are 3 components for replication. I only have 2 of them listed here. That's because the distributor component of SQL Server replication is not supported within an always-on availability group. So your only HA solution for that component of SQL Server is going to be failover clustering. Question is, can your system databases be an availability group? No, they cannot. So yeah, they are separate because they are instance specific and have to be up. Yeah, so his point is, if you do a failover from server A to server B, your logins may not be there. So I call that a process problem. Your DBAs need to have a process in place, and they need to understand they're deploying to an app that's supported by an availability group. So part of the deployment process now needs to be login gets created here. We now need to script out that login and create it here, here, and here. Same for jobs, same for SSIS packages, lots of little things inside SQL Server that, while supported, require that we push things out across the environment. For the login problem, the better solution is actually going to be to use contained users, because then we're actually storing the username and password inside the database. There's some caveats to that, but that's the best solution because then we just don't have to worry about it. And I like not worrying about stuff. I'm a DBA. Yeah. Why is there an asterisk by column store indexes? So column store indexes are fully supported in always-on availability groups, with the exception of up and through SQL Server 2014, you could not read a clustered column store on the secondary availability group. So that is fixed in SQL Server 2016. So basically, column store indexes are our columnar way of dealing with data, and so we can get fast reports off large amounts of data when we're doing big aggregations, big sums, big counts, stuff like that. So we can use these with the availability groups, no problem, works great. As soon as you fail over, you can read it on the second site. But because of some of the internals of how SQL Server works, I'm not going to bore you with the details, you can't read that column star index on the secondary until you actually do that failover. Again, that's fixed in SQL Server 2016. One of our clients has actually been doing that in production for about a year now. So if we want to do a hybrid scenario, what are our options? So we've got production on-prem and we want to do DR to the cloud or vice versa. Is this an option? And yes, this is absolutely an option. Up through SQL Server 2014, your only requirement is to stretch your Active Directory domain across the cloud and on-prem. That's a requirement of failover clustering up through SQL Server 2014. And then we simply install our instances on-prem, we install our instances in the cloud, and we set up the always-on availability group. As far as we're concerned, the cloud is just more VMs running in another site. They just happen to be running on somebody else's piece of hardware. So I kind of talked through this already. So we can do, kind of any of the normal configurations. Obviously, pick your region where you're going to store this data based on whatever your geopolitical requirements are, as well as your network latency. If you are going to push stuff up to the cloud, we are going to be pushing data to that new site constantly. So you need to make sure you've got a low latency connection or as low latency as possible a connection that you can get to that facility. I know most of the cloud providers now offer direct connections to their environment by things like in the Azure world, it's called ExpressRoute. Amazon has something, I can't remember off the top of my head what it's called right now. They will let you basically have a dark fiber connection to the cloud, and they will drop your network latency considerably to almost LAN levels of latency. That top bullet point is kind of an important one if you work for a multinational company. You need to be very careful about where you're putting customer data. For example, if you're based in the EU and you want to create or store your customer data in, say, the United States. That's all well and good until the government finds out. They're going to have a little bit of a problem with that. There's data locality issues you have to deal with when it comes to various countries. Obviously, typically we have a fairly low total cost of ownership up in the cloud because we're renting everything, so it's not CapEx. And we can only rent what we need. So if we need small for while it's in DR until it actually becomes production, we can rent small and then simply scale it up in the event of a disaster. So if we were to build this sort of environment in this particular case, Azure, but again, this will work basically the same way in any environment. Here we've got 2 nodes on-prem. We've got a 3rd node out in the cloud. We've got an always-on availability group set up between those. In this case, I would definitely have the multi-subnet configuration turned on where it registered both IP addresses, because odds are my users are going to be distributed across various sites since we've got this multi-site environment. We're going to set up a site-to-site VPN between whatever your cloud environment and your on-prem routers are going to be. At that point, the cloud is just part of your environment. So now we can just deploy these VMs and get the data moving and keep everything happy. So why do we want to do all this? Well, we want to protect from failure, obviously, of our on-prem environment. We want to keep our business up and running in the event of a total system failure. And building DR is expensive. I'm sure we've all built DR sites. They are very, very costly to spin up hardware and bring things online and keep things up and running in the event that we have to fail over to them. I'd much rather spin things up in some sort of cloud-based environment where I can get much less expensive cost for a long period of time, especially if I can get some licenses thrown in from Microsoft or from whoever the cloud provider is to help run some of those DR systems, where we can get some of those free licenses and leverage some of those free SQL Server licenses up into that cloud environment. So we get some additional benefits by running things in the cloud. Obviously, we get integrated HADR or HA within any of these cloud environments. That's the whole point of these cloud-based environments. We can offload our read-only workloads to these cloud-based platforms, so we can run reports out there. If you've got production inside A, but you've got users that need reports all across the world, we can push out copies with always-on availability groups to those various cloud-based data centers, and then the users can run those reports locally and get a much better response on those reports, make things much easier for the users to work with. We can migrate apps up to the cloud if those apps are read-only applications, and we can actually put those in the cloud and turn that part of the cloud environment into a production workload so that things are always running up there. We can offload all our backups to the cloud. One of our big requirements is always get your backups off-site. So if we take the backups off-site and we replicate them out to a third site, a second cloud-based site, we're doing that all at the cloud. We're doing that all at the wire speed provided by the cloud without impacting our local on-prem network. So lots of options there as far as dealing with these. And this can also give us some great checkboxes for compliance, because we can meet a lot of our compliance requirements by doing things like getting our backups out of our production data center. Big requirements, we need to make sure we have the same Windows Active Directory domain up there in whatever our cloud is, and it's got to be the same domain up through 2014, SQL Server 2014 and Windows 2012 R2. Now, that's all going to change right about now, because SQL Server 2016 introduced a bunch of new features. We actually have never seen this many new high availability features added in a single version of SQL Server. So let me throw all these up on the screen. There we go. I think that's all of them. Yeah. So there have been a few enhancements in SQL Server 2016. We can trigger failovers for the availability group at the database level, not at the server level. We've got support for distributed transaction coordinator. We've got better support for automatic failover. That's the 3 nodes that I talked about. We've improved log transport performance. I'm going to talk about all these more in detail. We've got load balancing for our readable secondaries, which is a really cool feature that Tom and I actually hacked together back in SQL Server 2012 at our TechEd keynote, and they introduced it to the product 2 years later. We have what we call a distributed, you forgot about that, didn't you? I built what they did 4 years earlier. We have support for group managed service accounts. We have distributed availability groups. We have what we call availability group seeding, and we have what we call domainless availability groups. So we don't need that Active Directory stuff anymore. So how are we doing on time? All right, I got 10 minutes and I got 12 slides. Awesome. So in SQL Server 2012 and 2014, all of the health of the availability group is monitored at the instance level. So if your database becomes corrupt, your database goes suspect, the disks fall out from underneath your database, none of these things will trigger a failover in SQL Server 2012 or 2014. What will trigger a failover in 2012 or 2014 is your instance going offline. We can now fix that in SQL Server 2016. As an optional setting, we can turn on database failure triggering. This will then cause your database health status to change when your database goes offline, which will then trigger a failover. So this can get you that extra layer of protection if your problem isn't that your instance goes down, if your problem is that your storage sucks. And this will then help solve that performance or that availability problem. One of the features that everybody really loved in SQL Server 2012 and 2014 was the fact that we could not use distributed transactions in an availability group. So this is things that are required by a lot of enterprise class applications, that we need to do these distributed transactions across multiple machines. Now in 2016, we have distributed transaction support. Now there's a couple caveats I'm going to throw up on the screen here. First thing is there's an OS patch that you have to install to make this work. No big deal. Yeah.
So in the earlier scenario, if you have like multiple databases, some of them are part of a availability group, and if the database goes offline, you fail over, what happens to the other database which is not a part of the group of that piece?
So the question is, if I've got an availability group and I've got databases outside the availability group, and the availability group fails over, what happens to the databases outside the availability group? So they are left alone. So failover happens at the availability group level. So if the availability group has 12 databases in it and you fail it over from server A to server B, those 12 databases become writable on server B. Any other databases on the server just stay exactly where they are. So if they're in a different availability group, that availability group will just stay where it is.
And the main operating system for this application is connecting via the
So the application is connecting to the availability group listener's name. So they will always follow that availability group listener wherever it goes, because it's got its own name and IP address. So the big requirement here for DTC support in SQL Server 2016 is that only a single database within the availability group can be enlisted within the transaction. So what this means is if I've got 10 databases in my availability group and I start a distributed transaction in one database, and then I run a query against the second database, it will still work fine, probably. It's just not supported. Now, where it's going to have problems is if you try to fail over the availability group while that distributed transaction that's touching multiple databases is still open. This is where things are going to get really hairy because the distributed transaction coordinator isn't going to be able to cleanly clean this mess up. So you're going to end up with just transactions that cannot be rolled back, and you're going to be on the phone with Microsoft, and they're going to tell you you did something you weren't supposed to do. So as long as you understand the limitation, as long as the application can work within that limitation, good to go. Works fine for single database commands. So log transport performance and automatic failover support. So in SQL Server 2012 and 2014, like I had mentioned earlier, we could only fail over to a single failover target. This has been changed in SQL Server 2016. We can now fail over to any failover target that is a synchronous copy automatically. We also have greatly enhanced the log transport performance in SQL Server 2016. So in 2012 and 2014, we could handle 98% of workloads. With 2016, we can probably handle 99.5% of workloads. Hardware enhancements have obviously driven higher throughput requirements. So Microsoft actually took all the transport code that they wrote for SQL Server 2012 and 2014. They ripped it out of the product, threw it away, and rewrote the entire thing from scratch. They invested several $1 million in rewriting this transport code just to get that extra 1% of systems that could actually take advantage of this. So this is dropping the CPU requirements for the transport pipeline. So we are getting better performance while getting lower CPU utilization on the boxes that are running this workload. The goal at Microsoft is to match the performance of standalone servers. I think that's an admirable goal. The laws of physics are not on their side. I'm really interested to see how they're going to build a wormhole into SQL Server so that they can move data from point A to point B fast enough. But I hope they can get closer. Right now, the stated performance that you're going to be getting if you have a synchronous copy is about a 2 to 3 millisecond latency at the high end for the boxes that are on the same network. That's about what you should expect to see. If you add in a second synchronous copy, your performance does not change. If you add in asynchronous copies, your performance does not change. It's only adding that first synchronous copy in that's going to add that 1 to 2 to 3 milliseconds of latency, which, again, 98, 99% of apps are going to be able to support without an issue. It's the really high end that people may have problems with those synchronous copies. So I mentioned this load balancing concept with what we call read-only routing. So back in SQL Server 2012 and 2014, with the read-only routing feature, would basically route all read-only queries to a single server. They would send them to one place, and that was it. So if my production copy's here, and my secondary, this is my readable secondary, all read workloads would go here. So we got a little bit of scale-out functionality back in 2012 and 2014. Now in 2016, we have what we call round-robin read-only routing. And it does exactly what it sounds like. If this is my production workload, or this is my writable copy, and these are my 3 readables, I can tell SQL Server to load balance all the workload across these 3 copies, and SQL Server will actually distribute the workload across those. So we get really good scale-out support across those 3 readable copies. And we can scale out across as many of those 8 secondaries as we want. And we can determine what order the round robin happens in. Now, it is just a basic round robin. It's not doing any checking to see what workload looks like or any of those boxes. There were a lot of discussions that some of us had with Microsoft as to how they should implement this. And frankly, my response to them was, this will be good enough for V1, just get it out the door and make it work well. And then go back and spend the time, if customers still want it, to do something a little more proactive, like checking for CPU workload and stuff like that, because that was all very expensive and they couldn't be sure it was going to be worth the investment. So we got this, and I'll take it. Yeah. Is there a GUI behind this? Of course there's no GUI for this. It's a 1%er feature. So there is no GUI to configure this. So I actually have a GUI that I built for this that I've got up on my company's website to help configure the read-only routing stuff, because the T-SQL for this can get rather lengthy. I'm ashamed to say I have not had the time to upgrade it for SQL 2016, but it will work with 2016. It just won't do the round-robin stuff yet. Yeah, it'll work fine for 2012 and 2014. It just queries the DMVs and gets all the data about the system. So one of the cool things for systems administrators is this group managed service support, or group managed service account support. What this does is it allows us to handle password changes without actually having to go do password changes for service accounts. So we can set up a group managed service account, configure that group managed service account to go work with all of our SQL servers in our availability group, and then we tell all those servers to run under that account. Whatever your password change policy is, Microsoft will automatically change the password for that service account, distribute that password to all the servers in the environment, and do so without having to restart the servers. That's always the big problem with doing password changes for system accounts, is I have to restart the services. Microsoft has come up with a way to do that without having to restart services and keep everything running. So this was supported back in 2014, sort of. It's now fully supported in SQL Server 2016. So all you got to do is upgrade, and you can take advantage of this very, very easily. Setting it up is pretty straightforward. We set up our group managed service account. We go into the service, and we simply tell it to use the group managed service account. Just put a $ at the end. That's how Windows knows it's a managed service account. It will then go to Active Directory and get the password. You never know what the password is. This is perfect for compliance as well. Because if you don't know what a password is and you cannot find out what a password is, you can't get in trouble. And let's be realistic, we're all about not getting in trouble at work. Now, distributed availability groups. These are, again, new in 2016. This basically allows a single availability group to treat a second availability group as a member to feed data across. I've got a diagram on the next slide that'll help make this look a little more clear. This allows availability groups to cross Windows clusters, which was not possible in 2012 and 2014. So if you have a Windows cluster in production and a Windows cluster in Windows Active Directory domain in production and a second Active Directory domain in DR, you can now move data between those in a single always-on availability group scenario using distributed availability groups. This is also fantastic for minimizing network traffic from site to site. This is one of the best use cases for this particular feature. So we were actually building an availability group for a client in Holland, and they were going to be replicating their data to Philadelphia. So they wanted 2 copies of that data in Philadelphia, but they didn't want to pay for the network bandwidth from point A to point B twice, because it's a fairly heavy write load application. So with the distributed availability groups, we're now able to meet that requirement because they only need one stream of data going across the network, and then the box that receives it on the second site will then pass that traffic on to the other server in the environment. This is also good workload for migrating between environments because, again, it makes it very easy to get this additional environment set up and just push that data across. So conveniently, here's that diagram that I was talking about. So we've got our availability group 1, which is our production workload in our production site. Off on our secondary site, we've got our secondary workload with our secondary availability group in a second failover cluster. And we've got our distributed availability group built around the whole thing. So the primary server here, it feeds all the data down to our secondary servers locally, just like we would expect it to, either synchronously or asynchronously. We can then feed that data over to the primary server in the second availability group in that second failover cluster. It will then feed that data down to its secondary server. So we have 2 servers in our DR site, but we're only paying for the network bandwidth for one set of network transport. So much less expensive option for moving data from point A to point B, because as we all know, network bandwidth is not free coming in and out of our sites. So this can be kind of a problem for moving stuff around. Another great new feature is called replica seeding. This is going to allow us to set up our secondary databases without taking a backup and a restore. We simply tell SQL Server, take this database, push it over here, and it will simply push all that data across. So no backup and restores is the big selling feature behind that. So I talked about Standard Edition. We do have availability groups in Standard Edition. I know I'm out of time. Sorry, I'll talk fast. So this is 2 nodes only. It is 1 database per availability group. There are no readable secondaries in this Standard Edition configuration. You can't take backups. You can take database snapshots. Basically, it's database mirroring. It's what you know from database mirroring that we've had for the last 11 years, just called availability groups and built with the availability groups engine. So same basic functionality. That's what they were shooting for there, was the parity that comes with that. So thank you all very much for coming. I do appreciate your time. Sorry I'm like a minute over. Don't forget to fill out your surveys for the sessions. I believe there's a QR code outside. And thank you all very much for coming, and see you later.